What is a trapezoid? Well, both a trapezoid and a kite is a type of quadrilateral. So let's start there. A trapezoid is a quadrilateral. Remember, that means it has four sides. That's all that it means. It is a quadrilateral that has the following properties. One pair of parallel sides. One pair of parallel sides. So in this picture, it's going to be this side and this side that we would mark to say parallel. Parallel arrow, but that's it. The other sides are not parallel, because if the other sides are parallel, what is it then? That's right, a parallelogram. Now these parallel sides, these are called the bases. Base there, base there. Doesn't necessarily have to be on top and on the bottom, but the bases are the sides that are the parallel ones. It might be on the top or the bottom. It's possible that the parallel sides would be next to each other like that. So here's another trapezoid where these are the parallel sides. One pair and only one pair of parallel sides. Those are called the bases. The non-parallel sides have a name as well. Those are called the legs. So this guy not parallel to this guy, those two sides are called the legs. Let's make a little note about that. The non-parallel sides are called legs. Okay, legs. Bases parallel, legs not parallel. Because there's a pair of parallel sides, there's a property that we know will exist in the trapezoid. Let's draw those parallel sides again over here. Now remember when we studied parallel lines that we have angles next to each other, such as this angle and this angle, one on one parallel line, the other on the other parallel line. They are obviously different in size, this one being obtuse, this one being acute, but they have a special relationship to each other. They are supplementary, adds up to 180 degrees. So there's the supplementary angles there, and there are the supplementary angles here and here. But that's it. Those two are not on parallel lines, and those two are not on parallel lines. So there are exactly two pairs of angles that are supplementary. Two pairs of supplementary angles. There's a trapezoid. Now we can have a specific kind of trapezoid, such as the isosceles trapezoid. So start with the trapezoid. There's exactly one pair of sides that is parallel. I'm going to color code to the trapezoid above. One pair of sides that is parallel are bases. Then the legs, the non-parallel sides, are congruent. Like an isosceles triangle, the legs are congruent. So in an isosceles trapezoid, there are congruent legs. So first of all, obviously it's a type of trapezoid, so we don't need to write that it's a trapezoid. Know that all of the properties for trapezoid are true for an isosceles trapezoid, but know that in addition, the legs are congruent. Now, just like a triangle, and I'm going to start off by showing the parallel sides in this trapezoid, just like a triangle, if there are congruent legs, there are also congruent angles. Remember how we called this a base and this a base, because the bases are the ones that are parallel? Well, there's also base angles. The two angles that touch the base will be congruent, just like in the isosceles triangle, right? Think back to the isosceles triangle, two sides congruent, two angles congruent. So just like that, two sides congruent gives us two angles congruent on this base. But I have two bases, so these angles are also congruent. So we have both pairs of base angles are congruent. So congruent sides gives us congruent base angles. Now, one last property is about the diagonals. If I draw in the diagonals of the trapezoid, now I said trapezoid, so I'm going to start by showing the one pair of parallel sides, just the one pair. Now I'm going to draw in the diagonals, and because the legs are congruent, it's going to cause these two diagonals to be the same length. How can we show that? 1, 2, 3. 1, 2, 3. The same amount of slashes. It's just that this short piece is not the same as this long piece. Otherwise, it would be a parallelogram. So we will say about this picture, the diagonals are congruent. Feel free to use the congruent symbol as long as you know what it means. Sometimes people ask, why do we have to learn about all of these special quadrilaterals? Well, these shapes are all around us in the real world. For example, the isosceles trapezoid is a key component of the stone arch bridge. The arch bridge is very common. They were built with stone before iron and steel bridges were introduced. A good example is seen below in this picture. The Romans, long time ago, used arch bridges throughout Europe, and many of them are still standing today as they are very strong. The keystone is one of our special quadrilaterals. It's the most important stone in an arch bridge. Without this stone, the arch would collapse. The keystone holds the arch together. So see how in this arch bridge right here, this stone right here that's called the keystone, that's a special shape. Can you tell what it is? One pair of parallel sides. The legs are congruent. That's an isosceles trapezoid. Let's take a look at this picture on how to build an arch bridge. How is it done? Well, they put the wooden structures, they build the bricks going up. The last part that goes in is the keystone. That isosceles trapezoid is how it fits in there. So they had to make those legs congruent in that trapezoid, in that one pair of parallel sides. All these other guys coming all along up the edge may be also certain types of trapezoids, or starting from down here, certain types of parallelograms. What kind of parallelograms do you think these are? Rectangles? Squares? You're probably right. This, however, is an isosceles trapezoid. So the more we know about these special quadrilaterals, the more information we'll have depending on what we end up needing to use it for in the future. Let's take a look at some examples using these properties of trapezoids and isosceles trapezoids. Find the angle measures of ABCD. ABCD means the quadrilateral, so I'm finding the angle measures that are missing here. First thing I notice is I have these parallel arrows, so that means this side is parallel to this side. Well, remember, one angle from one parallel line and one angle from the other parallel line, those have to be supplementary angles, add up to 180. So 180 minus 91, how much does that give us? 89? Let's put it in there. 89 degrees. The measure of angle D equals 89 degrees. When you're giving an angle measure, don't forget the degrees. Can you find the other missing angle, angle C? Why don't you pause the video, see if you can do it on your own. These two, one from one parallel, one from the other parallel, have to add up to 180. So 180 minus 132, 48. There you go. So the measure of angle C is 48 degrees. Again, when you write the angle measure, remember the degree symbol. How about number 2? Notice what's different about number 2 is that now I have an isosceles trapezoid. These sides are congruent. These legs are congruent. So of course I still have these two consecutive angles are supplementary. So I'm going to deal with that. 180 minus 53, 127. So this missing angle is 127. But I have a little bit, degrees. Measure of angle D, 127 degrees. But I have a little bit less work to do here because I know if the legs are congruent, so are the base angles. These two angles along this base, congruent. And these two angles along this base at the top, congruent. So there we go, an angle measure of 53 degrees for angle B, an angle measure of 127 degrees for angle C. What is a midsegment? It is a segment that connects midpoints. A midsegment can be for a triangle or a trapezoid. It is a segment that connects midpoints of sides. Now, for a trapezoid, it's going to be the segment that connects the midpoints of legs, specifically the legs. So let's show in this trapezoid how we have base parallel to base. The bases are the parallel ones. Therefore, I look for a leg. Here's a leg. Find its midpoint. Show that it's the midpoint by saying this part's congruent to this part. Now here's another leg. Find its midpoint. Show that it's the midpoint by saying this part's congruent to this part. Now I use different slashes because I don't necessarily have an isosceles trapezoid. Now I will connect midpoint to midpoint, and now I have a mid-segment. That's a mid-segment. A couple properties to know about mid-segments. It's going in the same direction as the bases, so it's parallel to the bases. So one thing we want to say about a mid-segment is it's parallel to the bases. That's one important property. The other important property is notice the lengths of them. This is the shortest, this is the longest, and this looks in between. In fact, it's exactly halfway in between, just like a midpoint is exactly halfway in between the two endpoints. So the length of it is exactly in between. How do we find exactly in between? We find the average. The length of the midsegment is the average of the bases. How do we do an average? Well, if we have two things, we add them, base 1 plus base 2, divided by 2. Average. Let's do some problems that deal with midsegment. Solve for x. Well, I see that this is a midsegment because it's connecting a midpoint to a midpoint. See the congruent marks? Tells me I have a midpoint. So if I'm looking for x, that's the length of this segment. I want the average of those. So I do 28 plus 22 and divide it by 2. I find the average. Usually it's best to do just part at a time. So I'm going to add up the 28 and the 22. That looks like 50. Divided by 2, 25. X equals 25. Do you want to try number 4, pausing the video and come back? This time I already have the midsegment. So think about how are we going to find this length right here? Well, remember that 12 is right in the middle. It has to be exactly in between this length up top and this length up down bottom for the other base. Well, a couple ways we can do this. One way perhaps to think about it is to go from 16 to 12. How many spaces away is that? 4. We have to go from 16 to 12 by subtracting 4. So to go from 12 to the top base, if I subtract 4 more, I get 8. That means 3x minus 1, the length of that top base, has to equal 8. Now I have an equation that we can solve. Add 1 to the other side and divide by 3. Good job.